Hello everyone, this is Satbir Malli. The topic of our discussion in this video is the logarithmic differentiation. We will learn these techniques by solving the various examples. My first example is the function y is equal to x to the power x, and we will calculate the derivative of this function by using some property of the logarithmic function. Before I calculate the derivative of this function, I would like to clarify one misconception about the derivative of this function, which is the derivative dy by df of this function. Some people are very tempted to calculate by using the power rule. So according to the power rule, the derivative of this function could be x times x to the power x minus 1. But unfortunately, this is not correct. This is a wrong technique. The very reason is that this function is not a power function. The power function, the variable is in the base, and the exponent is supposed to be a constant, it's not supposed to be the variable. So the power rule will not work here to calculate the derivative of x to the power x. There is another wrong way to calculate the derivative of this function is x to the power x to the power x times natural log of x. This, unfortunately, this is also not correct because this function is not an exponential function. This is the technique of calculating the derivative on exponential function where you have the constant in the base and the exponent is a variable. But in this situation, the both exponent and base, they are not one constant, another variable. They are both variables. So you cannot use these two techniques to calculate the derivative of this function. So let's see that if we cannot use the power rule and exponential rule to calculate the derivative of this function, how we will calculate the derivative of this function. So we will use some property of the logarithmic function along with some rules which we have learned in our previous videos. So let me first erase this board. So our function is, we will begin by writing down our function. So our function is y is equal to x to the power x. And first thing we will do that, we will take the natural log function on both sides to the problem. Then there is a property of a natural log. If natural log of m to the power n, which is called the exponent property, the n can be flipped over to the natural log. So I will use this property here to simplify the expression on the right hand side. So this will be x times natural log of x. And now I will calculate the derivative of the both side. One side I will use the chain rule, on the other side I will use the product rule. So differentiate the both side with respect to x. Differentiate both sides. We know that the derivative of d over dx of natural log of u is u prime over u. So instead of u, or u is a y, so the derivative of the left hand side will be y prime over y, and the derivative of this side will be using the product rule, which is the derivative of the first function times the derivative of the second function is as it is, and then first function is untouched, and the derivative of the second function, natural log of x. So derivative of x is 1, so I will multiply 1 by natural log of x, and the derivative of natural log of x is a 1 over x, which we learned in the previous video. This is a natural log of x plus 1, I simplify. So if I multiply, so what I have is now y prime over y is equal to natural log of x plus 1. I will multiply y on both sides. So my y prime will be y time natural log of x plus 1. So this will be also equal to y is x to the power x to the power x natural log of x plus 1. So this is my final answer. I will box my answer here. Let's do some more problems by using this technique. My next example is calculating the derivative of 2x plus 1 to the power 5 times x cubed minus 1 to the power 3. As you can see, this is a product of two functions. You can use the product rule and chain inside of that to calculate the derivative of this function. But if we use this technique of the logarithmic differentiation, you will see you have to do a lot of less calculation than will do calculating the derivative of this function directly by using the product and chain. So we will avoid this product and chain rule and use instead of the properties of the logarithmic function. So our function is y is equal to 2x plus 1 to the power 5 and x cube minus 1 to the power 3. I will take, my first step is always taking the natural log of y both sides. So I will take natural log of y, 2x plus 1 to the power 5 x cube minus 1 to the power 3. So I will use this property of natural log. The multiplication inside of the natural log is the addition outside of the natural log. So as I can see, this is a multiplication inside of the natural log, and it will turn into addition outside. 1 to the power 5th plus natural log of x to the power 3 minus 1 to the power 3. So this is my first property of use. The second property is again natural log of m to the power n is n time natural log of m. Now I will use this property. The exponent flipped over the log. So this property is a 5 time natural log of 2x plus 1. And this is a 3 time natural log of x cubed minus 1. Now my function is simplified. So I can take the derivative of this function because this side is expanded as much as I can. Now I will differentiate both sides with respect to x. So the derivative of this side is simply y prime over y, because this is the derivative of natural log is. Derivative of this function is a 5 times d by dx of the inside function, because here is a function u and the derivative of natural log of u is u prime over u, divide by 2x plus 1, and this is a 3, and the derivative of this function is d over dx is x cubed minus 1 divided by x cubed minus 1. So in the next step, I will calculate the derivative of the top and simplify also. So derivative of the top is 2. The derivative of this term is a 2. 2 multiplied by 10. So it's going to be a 10 divided by 2x plus 1. And this is a 3. The derivative is a 3x square. So this is a 9x square divided by x cubed minus 1. So again, this is a y over y prime. So in order to calculate y prime, I will multiply y on both sides. So I will get my final answer. This. So this is a y term, and that is this term which we calculated here. So this term multiplied by y. So and substitute y back. So 2x plus 1 to the power 5th x cube minus 1 to the power 3 and this. I have one more problem. We will practice this technique again. So my very first step to solve this problem is taking the natural log on both sides. So this is a natural log of x square x minus 1 square root of x plus 1. And next I will do that, I will basically simplify this one or expand the whole expression by using the property of the natural log. The very first property is the exponent property I will use. So exponent flipped over. So I will get natural log of x square x minus 1 divided by square root of x plus 1. And then the division inside of the natural log is the subtraction outside. So it's going to be natural log of x square and then x minus 1 minus natural log of, so this is a parentheses here, natural log of x square x plus 1 x plus 1 to the power 1/2. So this can be simplified as a pi. I can distribute pi, the natural log of x square x minus 1, and this is a pi, and 1/2 will flip over. This will be pi half natural log of x plus 1. And this, there is a product inside. I will use the property where say the product inside is the addition outside. So it's going to be a pi time natural log of x square plus pi time natural log of x minus 1 minus pi divided by 2 natural log of x plus 1. This is 2 will also flipped over, and that's my sort of last step is going to be 2 pi natural log of x plus pi time natural log of x minus 1 minus pi half time natural log of x plus 1. So this is the algebra to simplify the expressions on the right hand side. Now I will calculate the derivative on both sides. I differentiate both sides to finish this problem off. This is a y prime over y. Derivative of this is a 2 pi times 1 over x. Derivative natural log of x is this. And derivative of this is a pi times 1 over x minus 1. And this is a pi divided by 2 times. Derivative is a 1 over x plus 1. So if I multiply y on both sides, I can just simply move that y on the other side. So I will multiply y here. So when I substitute y back, because y is this, so I'm gonna substitute y back, and that will be my final solution to this problem, which is here. To simplify, this is my final solution to that problem. My next example is calculating the derivative of x raised to power sine of x. Again, we will begin by taking the log on both sides. So this will be a natural log of x sine inverse sine x to the power x. Since this is in the exponent flip over the log. So it's going to be a sine x time natural log of x. So this is a natural log of y. Now we will differentiate both sides to finish off this problem. So differentiating with respect to x. So the derivative of natural log is a y prime over y, and the derivative of this function is by using the product rule. Or in other words, dy by dx of sine x times the logarithm function as it is, the second function stay there, and then sine x times the dy by dx of the second function, which is the natural log of x. Derivative of sine is a cosine of x. So this is a cosine of x time natural log of x as it is, plus sine x, and derivative of natural log of x is 1 over x, which we learned in the previous video also. Therefore, if I multiply y on both sides, therefore y prime will be y time cosine of x time natural log of x plus sine x divided by x. And if I substitute the value of y from here, so the final answer will be, because I would like to have all my answer in x, so the final answer will be this. Why not we box the answer? So this is our derivative of that function. Let's do one more problem. This time I have sine x raised to power arc tangent of x, or tangent inverse of x. So again, I will begin by taking the log on both sides. So I will start this problem by taking the natural log on both sides. So natural log of y will be natural log of sine x to the power tangent inverse, or arc tan of x. The exponent will flipped over. So we have the arc tan of x time natural log of sine x. We use the property of the exponent. Exponent will flipped over the log. Now I will differentiate both sides. So differentiate with respect to x. We get this side is always same, y prime over y, because this is the differentiation of the function natural log of y. And here I will use the product rule, because this is the product of two functions. So this will be dy by dx of arc tan of x time natural log of sine x plus arc tan x as it is. We will take the derivative of the second function, which is the sine x, natural log of sine x. We know that the derivative of arc tan x from the previous video, 1 over 1 plus x square, and this function will stay as it is, and arc tan of will not change, same as it is. Derivative of natural log of, this is a natural log of sine x, so the derivative of this function will be the derivative of the top dy by dx of basically the inside function sine x divided by the natural log, which is the inside of natural log function, which is a sine x. So if we multiply y on both sides also, so y prime, so this complete derivative of that side. So if y prime will be y time this whole expression, which is a natural log of sine x divided by 1 plus x square plus arc tan x. Derivative of sine is a cosine x over sine x, which is also tangent x. So you will substitute the y value, which is a sine x to the power arc tan x, and we will basically substitute this expression natural log of sine x divided by 1 plus x square plus arc tangent x time tangent of x. That's the final answer. This is your final answer to your problem. We basically obtained in the last slide. Oh, sorry, I made a mistake here because this is a cosine x over sine x is cot x, not tangent x. So this is a cot x. This is a cot x. Which is here. Next, I have a clicker problem. This is a clicker problem number 3 to find the derivative of the function y is equal to sine x to the power x. Once you finish the problem, you can submit your answer in the link above. And there is another problem to master this concept is quiz problem number 4, where you have to calculate the derivative of x to the power natural log of x, and from this derivative you will calculate the slope of the tangent line at the point e comma e. If you have any question, please let me know. This is the end of this video. Thank you very much for watching this video, and if you like this video, please hit the like button and also subscribe my channel. Thank you very much for now. See you in the next video.